Good morning. Today we will discuss about the light emitting diode. As we have discussed in the previous lectures that the diode is the combination of P and N type material with appropriate impurities inserted into it. The we have various theories of emission of light. Earlier we have discussed about the spontaneous emission and stimulated emission. Spontaneous emission, as you know, is the usual theory with which the visible light emits whenever a electron jumps from high energy state to the ground state according to the principle H nu E is equal to H nu, that is the difference of energy of the two levels is emitted and frequency can be calculated by using this formula. There are various other methods by which we found the emission of electromagnetic radiations. You might have seen the red hot body, light coming out of a red hot body. Whenever you heat a body, you above a certain temperature you see the visible light. We call it as incandescence, is the emission of electromagnetic radiation from a hot body as a result of its high temperature. You might have read in lower classes that whenever you heat a body, slowly and slowly it will attain red color, then blue flame and so on. That depends on the temperature, and temperature you can calculate by using the simple radiation laws. Luminescence is the another process by which the light is emitted. It is the spontaneous emission of light by substance not resulting from heating of body or cooling of the body. Luminescence is a special character in certain substance, not in all substance. As you see in the tube light case also, that is the whenever electron hits at the surface of that material, what happens? The visual light spectrum is emitted. Electroluminescence is again an optical phenomena, or you can say is an electrical phenomena in which a material emits light in response to an electric current or to a strong electric field which passes through it. There are various other methods through which the phenomena of luminescence occurs, that is the chemiluminescence, sonoluminescence, mechanoluminescence, fractoluminescence, piezoluminescence, triboluminescence. As the name itself suggests, sonoluminescence means the emission of short bursts of light from impulsing bubbles in a liquid when excited by sound. Chemiluminescence means the emission of light as a result of the chemical reaction. Mechanoluminescence is the light emission as a result of mechanical action on certain solids. It can be used through ultrasound or through other mechanical methods also. Fractoluminescence is caused by stress that results in the formation of fractures. Piezoluminescence, you might have heard about the piezoelectric effect, which is related to the pressure, and so accordingly we define piezoluminescence. It is caused by the pressure that results only in elastic deformation. Then triboluminescence is normally caused by rubbing, but actually because of resulting fructoluminescence, so it often used a synonym. Uh, these are the various methods by which light is emitted. Now we concentrate upon the emission of light in light emitting diodes. Light emitting diodes, the basic use is the indicator in various electronic appliances. We usually confused LED with a laser torch indicator. That laser torch indicator is something else. Light emitting diode works on different principle than the principle of production of laser. A light emitting diode is a semiconductor light source that emits light when current flows through it. Electrons in the semiconductor recombine with holes, releasing energy in the form of photons. Now, what type of color will be produced, what type of light will be produced depends on the band gap according to the famous formula given by the Einstein. Delta E is equal to h nu, that is the difference of energies of the two levels, is equal to the Planck's constant multiplied by the frequency of the light. So accordingly, the band gap will decide the frequency, and white light is obtained by using multiple semiconductors or a layer of light emitting phosphors on the semiconductor device, because as you know, white light is the mixture of a large number of colors, you can say. That's why we use it like this. In the year 1962, the earliest LED emitted low intensity IR infrared light. As you know, the consumer electronics was not popular in the initial stages because the development of semiconductor physics was not so advanced in those days. So the discovery of LED was long back in the year of 1962, but the commercial use of LED was possible later on, almost all, you can say, after 1980 or even 1990, or you can say more explosive use of these type of devices was possible in the 21st century, you can say. In the early designs, LED were often used as indicator lamps, replacing small incandescent bulbs and in 7-segment displays. Recent developments have produced high output white light LEDs suitable for room and outdoor area lighting. Earlier we were using the normal bulb, say 40-watt bulb, 60-watt bulb, 100-watt bulb in our study room or bedroom. Then the concept of tube light, which was based on fluorescence concept. Nowadays we are using LED devices, LED bulb, LED tube light. Almost in each house or hotel or building, LED have replaced the usual bulbs or tube lights because of their low consumption of power. The lumen value or the light power which is emitted by this bulb is same, whereas electric power consumption is very low as compared to the usual bulb. That's why the usage of LED is becoming more popular nowadays. LEDs have many advantages over incandescent light source, including lower energy consumption, longer lifetime, improved physical robustness, smaller size, and faster switching. LEDs are used in applications as diverse as aviation lighting, automotive headlamps, advertising, general lighting, traffic signals, camera flashes, lighted wallpapers, horticulture grow lights, and medical devices. The light emitted from an LED is neither spectrally coherent or even highly, nor even highly monochromatic. As I told you, we shall never confuse LED with the coherent light, as the lasers are coherent but LEDs are never coherent, and the light emitting from a LED falls in the usual range. It is incoherent light, and I hope you understand the concept of coherent and incoherent. The basic difference between laser light and ordinary light is laser is coherent light beam, whereas the light emitted from other sources of light are incoherent. Its spectrum is sufficiently narrow that it appears to the human eye as a pure saturated color. Radiation of LED is not spatially coherent, so it cannot approach high brightness characteristics of lasers. This is the commercial design, you can say the block diagram of the construction of LED. Light inside light emitting diode. This is the emitted light beam, then the diode, then the transparent plastic case, thermal pins. Clearly the various parts of the LED are shown in this diagram.